Assalamu alaikum warahmatullahi wabarakatuh. In this video, we are going to solve question number 3 to 8, which are based on distance formula from the practice set 5.1 from the chapter Coordinate Geometry. Question number 3. Find the point on x-axis which is equidistant from a minus 3, 4 and b 1, 4. So let us assume the point on x-axis, let's point C. Let point C be on x-axis which is equidistant from a and b. So let us assume the coordinate of point C be x1, y1, coordinate of point A be x2, y2 and b be x3, y3. Let us assume. Now point C is at equal distance from A and B. Therefore distance AC is equal to distance BC. Therefore by distance formula, square root of here x1, y1. So distance AC will be x2 minus x1 square plus y2 minus y1 square is equal to distance BC. Distance BC will be here x3 minus x1 square. Since here x1 y1 c and x3 y3, so x3 minus x1 square plus y3 minus y1 square. Now substituting the value of x1 y1 and x2 y2 and x3 y3, we get here x2, that is minus 3 minus x bracket square plus y2 4 minus 0 bracket square, which is equal to x3 1 minus x1 is x bracket square plus y3 4 minus 0, y1 is 0 bracket square. Now squaring both the sides, taking square of both the side, taking square on both sides of equality. When you take the square of both the sides, the square root side will. After taking square of both the sides, we get therefore minus 3 minus x bracket square plus 4 minus 0 is 4 square is equal to 1 minus x bracket square plus 4 minus 0 4 square. Now simplifying these two brackets, applying the identity a minus b bracket square, here we will get therefore minus 3 square minus 2 times minus 3 into x plus x square plus 4 square is 16 is equal to 1 square 1 minus 2x plus x square plus 16. Now simplifying, therefore here 3 square 9, 3 minus into minus it will become plus, 3 2 the 6x plus x square plus 16 is equal to 1 minus 2x plus x square plus 16. Now both the sides of equality, which are the like terms, so here 16 same plus 16, so we can cancel, reduce, then plus x square will get reduced. Now whatever remain, take the variable on one side, so 6x minus this 2x will come on left hand side, it will become plus 2x is equal to 1 plus 9 will come on right hand side, it will become minus 9. Therefore 6x plus 2x is 8x is equal to 1 minus 9 is minus 8. Therefore x is equal to minus 8 divided by 8. Therefore x is equal to minus 1. So the point on the coordinate of point of x-axis, that is coordinate of point C, coordinate of point on x-axis, that is C is x comma 0, which is C is x is minus 1 comma 0. Fourth example, verify the points P minus 2, 2, Q 2, 2 and R 2, 7 are the vertices of right angle triangle. So now let us assume P 2 minus 2 to be x1 y1, Q be x2 y2 and R be x3 y3. Now using by distance formula, distance PQ, find distance PQ using distance formula. We have to prove that the triangle, the vertices of right angle triangle PQR are the vertices of right angle triangle. So distance PQ is equal to x2 minus x1 square plus y2 minus y1 square. So distance PQ is equal to square root of x2, that is 2, minus 2, that is 2 minus 2, 2 plus 2, and y2, 2 minus 2 bracket square, which is equal to 2 plus 2, that is 4 square plus 0 square, which is equal to 4 square, that is 16 plus 0, which is equal to root 16, which is equal to 4. So distance PQ is equal to 4. Now also distance by distance formula, distance QR is equal to square root of QR x2 y2 x3 y3. So x3 minus y3 minus y2 x3 minus x2 minus y3 minus y2 square, x3 minus x2 square plus y2 minus y3 square. So distance QR is equal to the coordinates x2 y2 and x3 y3. x3 is 2 minus y3 x2 is 2 minus 2 square plus y3 7 minus 2 bracket square, which is equal to square root of 2 minus 2 0 square plus 5 square. So distance PQ is equal to distance QR is equal to 0, that is square root of 0 plus 25. Therefore distance QR is equal to square root of 25, which is equal to 5. Distance QR is 5. Now here we have to find it. So again by distance formula, distance PR is equal to square root of under root. Now here x1 y1 x2 y2 x3 y3. Distance PR is equal to x3 minus x1 square plus y3 minus y1 square, which is equal to square root of x3, that is 2 minus 2, which is plus 2, is equal to y3 7 minus 2 bracket square, y1 is 2 bracket square. Therefore we get, which is equal to square root of 2 plus 2 4 square plus 7 minus 2 5 square, which is equal to 4 square is 16 plus 25, which is equal to root 41. So distance PR is equal to root 41. But PR square, that is root 41 square, is equal to 41, and PQ square plus QR square. PQ is equal to, from 1 and 2, PQ is equal to 4 square plus QR is 5 square, which is equal to 16 plus 25, which is also 41. Therefore, PR square of the greater side is equal to sum of the squares of the remaining two sides. Therefore, by converse of Pythagoras theorem, triangle PQR is a right angled triangle. Therefore, points PQR are vertices of right angle triangle. Question number 5. Show that the points P 2 minus 2 x1 by 1, Q 7 3 x2 by 2 are 11 minus 1 x3 by 3 and S 6 minus 6 x4 by 4 are the vertices of parallelogram. So using distance formula, distance PQ, where coordinates are x1 by 1, x2 by 2 is equal to, distance PQ is equal to under root x2 minus x1 square plus y2 minus y1 square. So x2 7 minus x1 2 square plus y2 9 minus y1 is minus 2. So minus into minus plus 2, 3 plus 2 bracket square, 7 minus 2 that is 5 square plus 5 square, 3 plus 2 5 square, 5 square is 25 plus 5 square 25, 25 plus 25 square root of 50. That is number 1. Distance PQ is equal to under root 50. Now distance QR, that is x2 by 2, x3 by 3 by distance formula, x3 minus x2 square plus y3 minus y2 square, that is x3 11 minus 7 square plus y3 1 minus 1 minus 3 square, 11 minus 7 4 square plus minus 1 minus 3 is minus 4 bracket square. Therefore, distance QR is equal to 4 square 16, that is minus 4 square 16. So under root 16 plus 16 is equal to square root of 32. So distance QR is equal to under root 32. Number 2. Now also finding the distance RS. Now for the distance RS, by distance formula, that is distance RS is equal to x4 minus x3 square plus y4 minus y3 square, that is x4 is 6 minus 11 square plus minus 6 minus 1, that is plus 1 bracket square, 6 minus 11 square plus minus 6 plus 1 square, that is 6 minus 11 minus 5 square, and minus 6 plus 1 is minus 5 square. So minus 5 square is 25 plus 25. So distance RS is equal to under root 50. Third one. Now distance PS, that is x1 by 1, x4 by 4. So x4 minus x1 square plus y4 minus y1 square, that is x4 is equal to 6 minus 2 square plus minus 6 minus will become plus 2 square, that is 6 minus 2 4 square plus minus 6 minus plus 2 is minus 4 square, 4 square is 16 and minus 4 square is 16. So distance PS is equal to square root of 16 plus 16 is equal to 32, number 4. So from the first, second, third and fourth we get that this distance PQ is equal to distance RS root 50 and distance QR is equal to distance PS, that is root 32. Therefore, here opposite sides of this quadrilateral are equal. If opposite sides are equal, then the quadrilateral PQRS is the parallelogram. Therefore, PQRS are the vertices of parallelogram. Sixth example, show that points A minus 4 minus 7 x1 y1, B minus 1 2 x2 y2, C 8 5 x3 y3 and D 5 comma minus 4 x4 y4 are the vertices of rhombus ABCD. So by using distance formula, find the distance AB. Distance AB is equal to x2 minus x1 square plus y2 minus y1 square. So square root of x2 minus 1 minus 4 will become plus 4, minus into minus plus y2 2 minus 7 minus into minus plus 7 bracket square. 4 minus 1 3 square, 2 plus 7 9 square, 3 square 9 plus 9 square 81 is equal to under root square root of 90. That is distance AB. Distance BC is equal to, by distance formula, x3 minus x2 square plus y3 minus y2 square. So square root of x3 8 minus 1 will become plus, minus into my plus 1 square plus y3 5 minus 2 y2 2 square, 8 plus 1 9 square plus 5 minus 2 3 square, that is 9 square 81 plus 3 square 9 is equal to under root 90. Number 2. Also now distance, by distance formula, distance CD is equal to x4 minus x3 square plus y4 minus y3 square. So under root, it is x4 is 5 minus 8 bracket square plus y4 minus 4 minus 5 bracket square, 5 minus 8 minus 3 square plus minus 4 minus 5 minus 9 square. So 3 square, that is minus 3 square 9 and minus 9 square is 81. 9 plus 81 90. Distance CD is equal to square root of 90. Number 3. Now distance AD, x4 minus x3 square plus y4 minus y1 square. Here x1 y1, x4 y4. So by distance formula, x4 5 minus x1 is minus 4, so plus 4 bracket square, minus 4 again minus 7 minus into minus plus 7 bracket square. So 5 plus 4 9 square, minus 4 plus 7 is 3 square, that is 9 square 81 plus 9, which is equal to square root of 90. Number 4. Now from 1, 2, 3 and 4 we get that distance AB is equal to distance BC is equal to distance CD is equal to distance AD, which is root 90. Therefore all sides are equal. Since in a quadrilateral, if all sides are equal, then quadrilateral is said to be a rhombus. So here the quadrilateral ABCD is a rhombus. Therefore points A, B, C, D are the vertices of the rhombus. Find x if distance between L, x7, x1, y1 and m1, 50 is 10. We are going to find value of x. So here given is distance, that is distance ln is equal to 10. So by distance formula, distance ln is equal to square root of x2 minus x1 square plus y2 minus y1 square is equal to 10. Substitute the value of x1, y1, x2, y2. So x2 1 minus x1 is x square plus y2 15 minus y1 7 square is equal to 10. Now taking square on both the sides, taking square on both sides of equality, squaring both the sides means squaring LHS and right hand side. will get here. Therefore 1 minus x square plus 15 minus 8, that is 8 square, is equal to 10 square is 100. Now expand this term, x a minus b bracket square. Therefore 1 square, that is 1 square minus 2 times 1 into x plus x square plus 8 square is 64 is equal to 100. Therefore 1 minus 2x plus x square plus 64 minus 100 is equal to 0. Therefore rearranging the terms, x square minus 2x 1 plus 64, that is 65, and minus 100 is minus 35 is equal to 0. Now this is the quadratic equation. So factors of minus 35, such factors, middle term should be minus 2 x, so 7 5s are 35, minus 7 plus 5 are the factors, so that we get middle term as minus 2, minus 7 plus 5 is minus 2, so split the middle term. Therefore x square minus 7x plus 5x minus 35 is equal to 0. Taking common from making the group of two terms, take the common x minus 7 plus 5 on the 5 and 5 7s are 35 is equal to 0. So first bracket x minus 7 and second bracket x plus 5 is equal to 0. Therefore x minus 7 equal to 0 or x plus 5 is equal to 0. Therefore get x is equal to 7 or x is equal to minus 5. So values of x are 7 and minus 5. Eighth example, show that points A 1 2 x1 y1, B 1 6 x2 y2 and C 1 plus root 2 root 3 comma 4 x3 y3 are the vertices of an equilateral triangle. So using distance formula, distance AB is equal to x2 minus x1 square plus y2 minus y1 square is equal to under root of x2 1 minus 1 square plus y2 6 minus 2 square 1 minus 1 0 plus 6 minus 2 4 square, which is equal to 0 square is 0, 4 square root 16 is equal to square root of 16 is 4, number 1. Also again by distance formula, distance BC is equal to under root x3 minus x2 square plus y3 minus y2 square. Therefore distance BC is equal to x3 1 plus 2 root 3 1 plus 2 root 3 minus x2 1 square bracket square plus 4 minus 6 bracket square. Now 1 minus 1 0, that is 2 root 3 square plus 4 minus 6 minus 2 square is equal to 2 square is 4 root 3 square 3 4 into 3 plus minus 2 square is 4, that is 4 into 3 is 12 plus 4, which is equal to distance BC is equal to 12 plus 4 root 16, which is equal to square root of 16 is equal to 4, number 2nd. Also by distance formula, distance AC is equal to x3 minus x1 square plus y3 minus y1 square. Therefore x3, that is 1 plus 2 root 3 square minus x1 is 1 square plus y3 4 minus y1 is 2 square. Therefore here 1 minus 1 0, so 2 root 3 square plus 4 minus 2 is equal to 2 square. Therefore 2 square is 4 and root 3 square is 3, 4 3s are 12, 12 plus 2 square 4, 12 plus 4 is equal to 16, root 16 is equal to 4. So from first, second and third we get distance as 4. So distance AB is equal to distance BC is equal to distance AC. So all sides here are equal. So if in a triangle all sides are equal, the triangle is said to be an equilateral triangle. Therefore, your triangle ABC is an equilateral triangle. Therefore, points A, B, C are the vertices of an equilateral triangle.